All right, everybody, this is going to be 6-5, day 2, just a few more examples that we're going to walk through just to make sure everybody's okay. So we'll do a few more practice problems and make sure we're good. So I want to just talk through again, amplitude period. What happens with the phase shift, vertical shift, and is it reflected? So trying to hit some of the pitfalls that people run into. So let's take a look at the first one. I'd like you to go ahead and pause the video and see if you can make the list for yourself. So the amplitude period, everything. See what you think and then check back in, turn it back on and see if we are in agreement. So first thing, amplitude should be 1. Most common wrong answer is the 3. You get so conditioned in thinking, oh, the first number I see, that must be the amplitude. Only if it's multiplied with the cosine function. The 1 is the amplitude. The 3 is actually the vertical shift. So anything that's added or subtracted is a vertical shift, whether it's added in front of the function or afterwards. Vertical shift. Is this one reflected? No, because the 1 out front isn't negative. Period. 2 pi divided by, here's another common error. It's 1 over 2, so 2 pi divided by a half. In other words, remember what your k value means. If k is a half, that means you'll only see half of your graph in 2 pi. So that means it's going to take a full 4 pi, multiplied by the reciprocal, to get through the entire graph. Is there a phase shift? Well, no. What's your visual cue for having a phase shift? Well, it's having parentheses, adding and subtracting inside. There isn't any, so we know we don't have a phase shift. Okay, when I set these up, we have to think about what this is going to look like. Set up our axes first, and then we'll go ahead and do the graph. So our period is 4 pi, which is a wonderful amount because that means the middle would be 2 pi, 1 pi, 3 of those, 3 pi. All right, let's think vertical scale for a second. The amplitude is 1. That means the maximum will occur at 1. However, we're shifting the graph up 3. So where would your new maximum be if we're shifting a 1 up 3? Well, that would be at 4. So I want to make sure I plan ahead in my scale here. So I'm going to have to go all the way up to 4. The minimum would have been at -1. So again, I'm shifting up 3. So if you shift a -1 up 3, where would you be at? So -1 plus 3 would be at 2. So my scale should be fine. Just for having 1 down there, I guess I'll put a -1, but it's going to be shifted up. I'm not going to need that. All right, so I have my scale set up. Now, where's your new middle of the graph, that midline? Whatever your vertical shift is, that's where the new middle of the graph is going to be. So that's moving up to 3. So I just can't emphasize enough how important I think it is to put in that new middle of the graph. So this midline, we call it, is y equals 3. It's that new middle of the graph, your new frame of reference. So this entire graph is going to be shifted up 3 units. Okay, so today on these, I'm going to try to do this where we're not actually having to do an original graph and then shift it. We're going to do the whole thing at once. So this is a cosine graph. So cosine normally starts at its maximum. So our maximum before was 1 with a regular amplitude of 1, but now we're moving up 3. So it's going to start at a height of 4. There's no phase shift, so don't have to worry about going left or right. So just think of it up 4, so we just move that first, or up 3, we just move that point up 3, so it's at 4. Another way to think of it is it always starts the amplitude above where the middle is. So our new middle is at 3. If the amplitude is 1, that means from 3 I would have to go up 1. So if you want to just think of what does the amplitude tell you, from the middle to the top, that's amplitude. So it goes up 1. Okay, so from there, cosine goes from the max down to the middle. So the new middle of the graph is at 3. So at that first interval at pi, we would be at 3. Okay, then it goes down to the minimum. So the minimum is going to be occurring at 2 pi. Now, 2 ways to think of it again. The minimum normally would have been at -1, so if I move it up 3, it would be at 2. So that's one way to think of it. Otherwise, think of it, it's 1 below the minimum, or the middle, sorry. So if the middle's at 3, 1 below would be 2. So I know I'm going down 1 unit. And then we go back to the middle, and back to the maximum. So we can have our nice, smooth, continuous curve. Don't forget about the arrows. They'd be curving back down, and that graph would continue infinitely in both directions. All right, so we did our entire final graph all in one. If you'd prefer to shift it up, totally fine. You can definitely do that. Okay, let's take a look at the next one here. I'm going to try to list off what we know and then make a quick sketch. So I'll try to go through these as quickly as I can here so you can have a good look at what we need. Alrighty, so let's list off what we know. Pause the video if you need to, and then we'll Go ahead and make your list and check in. So amplitude is 2, period would be 2 pi, 2 pi divided by 1. So remember the k is a 1, so that would be 2 pi. We do have a phase shift this time. It's going pi and to the right because it's a minus. Remember your couple ways of looking at it. Whatever the number is in there, if that k value is a 1, well, that's your phase shift. Otherwise, just set that equal to 0 to see how far you've shifted from 0. Solve for theta. That's your phase shift. So we're going pi to the right. Vertical shift is up 3, and it is not reflected. There's no negative out front. Okay, so let's set up our scale to be appropriate for that period. So 2 pi. So that would be pi over 2, 3 pi over 2, our regular scale. Now I'm going to go ahead and make some adjustments, plan ahead here. I know I'm going to be phase shifting pi to the right. So pi is 2 of our intervals. Pi over 2 is 1, so 2 intervals would be pi. So I'm going to have to add 2 tick marks. We need to label them. So the next one, 1 tick mark or 1 interval past 2 pi. Well, each interval is worth pi over 2. That's the 5th interval, so that would be 5 of those, 5 pi over 2. Or you can count up 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Next one would have to be 5. So what would the next one have to be? Well, that would be 6 pi over 2, which is the same as 3 pi. If you look at the pattern, every other one is whole number. So 1, 2, 3 kind of makes sense if you look at that. So plan ahead, make sure you know what your scale is going to be. Okay, amplitude is 2 this time. That means the max point would be at 2, the min would be at negative 2. However, we're shifting up 3. So if your maximum was already at 2 and you're shifting up 3, where would your new maximum point be now? Well, it would be up at 5. So we're going to go ahead and make sure we plan ahead, especially when you're doing these close together. You don't want to start graphing it and realize you're going off the paper or something. So our new middle of the graph is going to be at 3. So really helpful to have that mid graph in there, so that midline, so we can see where we're going. All right, so we're going to try to do this all in one again. So we're going to do just like you would for a parabola. If you were going to go left and right and up and down, you do that all at once to see where that first point starts. So think of it like that. How far do I go left and right, and how far do I go up and down? All right, so sine graph normally starts in its middle. So the middle now, because I shifted up 3, would be at 0, 3. So normally I would be starting now at 0, 3, because this whole graph moved up 3. So my vertical shift was 3. But it's also going pi to the right. So not only do I have to go up 3 to find the new middle, I'm going to have to go to the right 2 intervals, or pi radians. So I'm going up 3 over 2. Just like you would for any other parent graph. So I'm shifting to the right 2 units, pi, and up 3. So sine starts in the middle. That's where that first 0, 0 point would translate to. Now you can just follow the pattern from there. So think about where those would go. After the middle, it goes to the max. So at 3 pi over 2, it's going to be at its maximum. The maximum is the distance from the middle up the amplitude amount, so it's going to be up at 5. We already talked about that. If the max normally amplitude was 2 and you move up 3, you're going to be at 5. So just don't forget, the middle to the top has to be the amplitude number, so it's a height of 2. So be careful. We preserve that amplitude number when we shift. Then we go back to the middle, so at 2 pi it would be at 3. Minimum, okay, be careful here. At 5 pi over 2, we have to go the amplitude down. So I'm going to go 2 units below, which would be at 1. So 3 minus 2. But remember, another way to do this is amplitude was 2, so the original graph would have had a minimum at negative 2, but I'm moving that point up 3. So if I start at negative 2 and I move up 3 units, I would be at positive 1. So whichever way is easier for you to think of it. A lot of people just follow the pattern, but the amplitude still needs to be 2. And then back to the middle. So we're doing our smooth continuous curve, and we have our points. So it's a real quick and easy way to be able to do that. Do the left, right, and up, down all in one step. Okay, we're going to try a couple more graphs just to make sure people are good with this. So let's try the next one. I want you to list everything you know, and then we're going to go ahead and make the sketch. So go ahead, pause the video, list what you know. So amplitude would be 2 from the 2 out front. Period, 2 pi divided by 1, so 2 pi. Phase shift is going to be pi over 2, but because it's a plus, that means it's a negative shift. So plus means minus a negative, so we're actually going to the left. So if I see you write down a negative sign, it means that you're going to the left. Vertical shift, this one's going up 1, and it's not reflected, so I don't have to worry about a reflection for this one. Okay, so let's go ahead and set up our scale. So we're going to do our 4 tick marks to be the original period. period. We always want to start with that so we know we can have that complete graph. And then we'll adjust if we need to here. Okay, we need to go pi over 2 to the left. All right, so I'm going to have to go move my graph to the left, so back. So if I put one tick mark in the negative direction past the y-axis, what would that label be? Well, each interval is worth pi over 2. If I went to the left, this would be negative pi over 2. Is that enough to be able to do our shift? Well, that's exactly the shift, right? We're going back pi over 2, that would be 1 unit. So that should be plenty for our horizontal scale to get the whole graph, one complete cycle. It continues infinitely, but we're showing one cycle. Vertical scale. It looks like we have an amplitude of 2 again, so the height of the graph is going to be 2, but we're shifting it up 1, which means my new maximum is going to be up at 3. So when I think about where this is going, I got to be careful. I need to make sure I plan ahead. So 1, 2, 3. We'll do some of the negative direction as well. So your new middle of the graph is happening at 1. Okay, so let's see if we can do this all at once. There's your new midline. So we are going to start, cosine usually starts at a maximum. It still will be a maximum because it's not reflected. So because I am starting with my vertical shift up 1, the middle would be at 1, so the maximum would be the amplitude above that, or 2 units above. So my first point, if it's not shifted left or right, would have been at 0, 3. Because think about it, initially it would have been at 2, amplitude was 2, so the maximum should have been at 2, but I moved this whole graph up 1, so now it's at 3. So think about amplitude, it should be 2 above where the middle of your graph is. If the middle's at 1, it should be up at 3. Now that's not our final location though, because remember, not only did it go up 1, it goes over pi over 2 to the left. So I'm going to go pi over 2 to the left. The first actual point on my graph then is going to be negative pi over 2, 3. So it's 2 units above the middle, and it shifted pi over 2 back. So think of it, you went left 1 and then up 1 from where that original point was going to go. So I moved it over. So normally it would have been at 0, 2. So I went left 1 and I went up 1. Okay, now where does that cosine graph go from there? Well, it goes to the middle. So the middle now is going to be at 1. So what should have been at our next point here, our 0 here, is going to be up at 1, middle of the graph. So it shifted back 1 unit from where it normally was. So it goes to the middle next, which happens to be at 1. Okay, where does it go from there? It goes to the minimum. Well, minimum has to be 2 underneath the middle. So at pi over 2, it would be down 2, which would be at negative 1. So the amplitude still should be 2. Think about that if that makes sense. Amplitude is 2, so the minimum normally would have been at negative 2, but now we're shifting it up 1, so it would be at negative 1. Back to the middle at pi, and then back to the max at 3 at 3 pi over 2. So we get our nice smooth continuous curve. We shifted left 1 unit, or pi over 2, and up 1 unit to 1 for the middle. So we're just moving that graph over. So if you need to do it in multiple steps, great. If you can do it all in one, fantastic. Okay, let's try another one. This is kind of the big kahuna. This is pretty much everything that can happen when you do this. So let's go ahead and see what we can do for our labels here. Go ahead and pause the video and then see what you get for amplitude, period, and everything down the list, then check in. All right, so amplitude's 4. Period is 2 pi divided by 0.5, or a half, which means 4 pi. Again, it's twice as long. You only get through half the graph. So this is your K value. We only get through half the graph, so it would be 4 pi long. Phase shift would be pi over 2. Now, I think in class, I did it as a plus sign. So just so we can have another practice going to the left. So I'm going to go ahead and do it that way because the kids in class did that as well. We could do it as a minus, but I think it's helpful to do a couple that are to the left. We did a lot to the right, so let's try one to the left. So if it's a plus in the middle, that would be minus a negative, so it would be to the left. Vertical shift would be up 3. Is it reflected? It is. So this is a graph that is also reflected. All right, so let's get our scale set up here. On the x-axis, we for sure need to make sure that we have 1 complete period. So we'll get that listed in. All right, now this phase shift is going to go pi over 2 to the left. Now, our intervals, though, your scale is going by pi. So if I'm going to put another tick mark over here, it has to be at the same interval as all the other ones. So I'm going by pi's to the right. It has to be going by pi's to the left. So that means this first tick mark would be negative pi. How would you show a pi over 2 phase shift then, if my first interval is negative pi, well, half of pi, just go halfway in between. So it's no different than if you're graphing, say, a parabola, and you're going by ones and your vertex is at a half. Well, go halfway in between. So we can definitely estimate like that. So I think that should be fine for that scale. Let's talk about the vertical scale. Amplitude this time is 4. So we're already starting at a positive 4. And then it's going to go vertical shift 3 more. So that means we're going to have to be all the way up at 7 to be able to see this whole graph. So think ahead a little bit. It really saves you some time when you're trying to do that graph. The minimum of the graph normally would have been at negative 4. We're going to go up 3. So your minimum would actually be at negative 1. So this graph is going to be going back and forth between positive 7 and negative 1. Okay, your new middle. However you want to show that. Some people do a dashed line, some people do a very light solid line, so you know where that value is going to be, whatever makes sense to you. Okay, so where does cosine normally start? Normally starts at your maximum, but this graph is reflected, so it's going to start at the minimum. So where would the minimum be? Well, it's going to be 4 units, your amplitude is 4, below the middle. So if the new middle is 3, 4 units below would be at negative 1. So again, it was at negative 4, now it's moving up 3, so it'd be at negative 1. That's where the minimum would be. Now, I've made it really light because that's not the final location. That not only has to be up 3, which I just moved it up 3, it also has to be pi over 2 to the left. So pi over 2 to the left means halfway between 0 and negative pi. So this first location, I'll make this point really big so you can see it, is halfway between 0 and negative pi, and it's at negative 1. In other words, 4 units below the middle of the graph. Okay, so it starts at the mid. Now it goes to the middle. So this next point, instead of being at pi, that's my 1 unit over, at pi 3, which would be the middle of the graph, it's going to be half a unit again back. So it'd be halfway between 0 and pi. So that's the middle of the graph, so at 3, but I'm shifting it back pi over 2 as well. Okay, then where does it go? Well, at pi over 2 and then shifted, it should be at the maximum. Well, the maximum would be up at 7 then. The amplitude is 4, remember, so it should be 4 units above the middle. So 4 above 3 would be 7. But again, we have to slide it pi over 2 back, so it'd be halfway between pi and 2 pi. We'd reach our maximum. Then at 3 pi, it should be back to the middle, but again, shifted back. So halfway between 2 pi and 3 pi, it should be at the middle. And then it goes to the min. So at 4 pi should be at the minimum. Again, that would be negative 1, but shifted back, so halfway between. So all of these points shifted back pi over 2. So smooth, continuous curve. Remember your arrows so you can show that it would be going back up towards the minimum. And we did the whole thing in one step. If you can do that, that's phenomenal. If you need to show multiple steps, also fine, but I think most people move it just like they would a parabola or absolute value. Move that first point, the max or the min, the middle, whatever it is. Move that first point, then follow the pattern, and you should be able to graph it. Okay, last thing, just to do one more example. Of writing an equation, so just making sure we can get everything in there. This is a cosine function. So we have our amplitude, our k that tells us something about period. You can use x or theta for your angle, minus the phase shift, and then plus the vertical shift. So just kind of some reminders. We've got A for amplitude. We've got K that tells us something about our period, so 2 pi divided by K. We have our phase shift, so X minus the phase shift. How far has it been shifted from 0? And then the H, which is your vertical shift. Alrighty, so let's see if we can write this equation. Most things we're just going to be substituting in. The only thing you have to solve for is the period. Okay, so they say the amplitude is 3, so it's been vertically stretched. So remember that could be coming from a positive or a negative 3, so plus or minus 3. Cosine of, let's talk about K. It says the period is half of pi. So pi over 2 is another way to say that. So if it is only pi over 2 to get through one complete graph, how many graphs could you see then? They're pi over 2 each and 2 pi. In other words, how many half of pi's could you have to make 2 whole pi's? Well, you need 4 of them, so K is going to be 4. If you can figure that out, that's phenomenal, but you don't have to. You can just use the formula. So 2 pi divided by K, your period is pi over 2. That equals 2 pi over K, and you can just solve for K. So cross multiply, and then divide by pi. So k would have to be 4. So whatever way is easiest for you to think that through. But the ones that are divisible in multiples of 2 pi, it makes it a little bit easier to figure out, oh, yep, that's a 4. So if it's only half of pi, super compressed, lot shorter than the original, you could fit 4 graphs in 2 pi. All right, if there's a phase shift, then we definitely need parentheses, and there is, so go ahead and use your parentheses. X or theta, your choice. The phase shift is negative. That means minus a negative, which is the same as plus positive, so a lot of people just say plus, and then your phase shift is pi over 4. So if you see x plus pi over 4, that means it's going pi over 4 to the left. And then a vertical shift, it's going down 6, so minus 6. Works great, and I have everything in there that I need that would model that situation. And again, I know we talked about this. You can also do what I'm doing right now. See if you can see what I did. I distributed through the 4 into the parentheses, and that would be fine too. If you're using your graphing calculator, the red one might be a little bit easier way to go. All right, so just a few more examples to help you with graphing, and I think we should be all set. So be courageous. See if you can graph it all in one step. If you need to do multiple, totally fine.